All right, so this is part 2 of the word problem video. I'm going to work through problems 4, 5, and 6. There's a little bit of a change in these because some of them are talking about percentages of change, and so we want to be careful about that. But as always, read it, annotate it, understand the information. All right, in January of 1992, Champaign, Illinois had a population of 80,000 people. If the population increases 1.5% each year, what will be the population at the end of 2010? Okay, so we want to be careful with this. We know a couple things. We know U sub 1 is equal to 80,000 people. We know our R value is, this is where it's going to get a little strange. All right. I know that my population is increasing 1.5%, but that's not what R is equal to. R is equal to 100% plus the percent of increase. So in this case, it would be 101.5%, which as a decimal is equal to 1.015. All right. So again, why did I do that? Because the population is increasing 1.5%. Well, it's increasing from what? Well, the what it's increasing from is its current full population. And so that current full population is represented by 100%. That's everybody who lives in Champaign. And now we're going to add on 1.5%. So I added them together, 101.5, turn the percent into a decimal. Either move the decimal places 2 places to the left or divide by 100. Either way, you're going to turn it from a percent to a decimal. So that's so much we know so far, and then I need to know how many years are we talking about. And this is a little bit weird because we're starting in January of 1992, but we want to get the population at the end of 2010. So from 1992 to 2010 is 18 years. But there's an extra year there because we're not starting and ending in the same place of the year. So January of 1992, 18 years would be January of 2010, but I want the end of 2010, so it's actually 19 years total. I know that's a little bit weird. Hopefully it's okay. All right, so I want to know that population at the end of 2010, so I'm going to be looking for U sub 19 is going to equal my first term times my common ratio. Percent of change problems are ratio problems. Okay. 100% this is going in a calculator, and I'm actually going to do it right now. Make sure I get all my zeros there, because I would like to see. All right. So this is equal to 104,587.2509, and I'm sure there's more stuff after that. This is a population problem, and we're actually going through the census right now in 2020. When you count people, you count whole people. Okay, I don't care if you're extra tall, you don't count as more than one person. I don't care if you're a little on the shorter side like myself, you don't count as less of a person. So all of these decimals we are going to completely ignore. All right, this is an approximation, and so we're going to say it's approximately 104,587 people. If this had been 0.6, 0.7, something like that, and you felt the need to round up, that's completely appropriate for this problem. Okay? Okay. All right. It's problem number 5. Johnny was born. His parents put $5,000 into a savings account to go to college. Each year for his birthday, his parents added 5% of the current value. This happened for the next 18 years until he graduated. He got access to the account. how much money will Johnny have in his account for college? All right, so things I know. I know U sub 1 is equal to 5,000. So U sub 1 is where we started. It has been 18 more years, so total of 19 years here. And R is equal to, remember this is not just 5%, it's 5% being added to the current value of the account. Well, the current value of the account would be 100%. Whatever's in there is all of it. And we're going to increase that by 5%. So 105%, which translates into 1.05 as a decimal. And yes, you need to use a decimal when you're using the formulas. So how much money is in the account? U sub 19 is going to equal 5,000 times our rate of change raised to the 19 minus 1. Go ahead and put that in a calculator because I have no idea what 1.05 raised to the 18 is. But I do know that he would have $12,033 and I'm going to call it 10 cents. So in the calculator, I've got 12,033.09617. Again, there's more stuff after this. Why am I giving you decimal values here like I did in the last one? Well, in this case, we're talking about money. And it absolutely makes sense to talk about dollars and cents. So we have dollars, and then we have cents. But I only want to look at the first two here. So I've got the 0, 9. The 6 after the 9 is what made me round it up to 10 as opposed to 9 cents. All right. Please understand if your rounding is different than mine, if you are really close to mine, I'm talking close as in pennies close, it's okay. If you have rounding errors early in your problem, they're going to compound later on, and that'll cause other issues. So this is one of the reasons why I put this whole thing in my calculator at once, because that way I don't have to worry about rounding anything except the final answer. Okay, last problem. All right, read it, annotate it. You know the drill. Okay, Rex Cars bought a Ford Mustang GT that cost him $33,000. Rex has never been able to keep a car for longer than 7 years before he totaled it. I don't understand that, but hey, to each his or her own. The value of the Ford Mustang depreciates 12% each year. What will be the approximate value of the car at the time that Rex should expect to total it? Well, Rex needs to learn how to drive a little bit better, but that's a different story. All right, Rex bought a car, $33,000. So U sub 1 is equal to $33,000. He knows he's only going to have each car for 7 years, so N is equal to 7. Now, depreciation. Depreciation is what happens when you buy most material things. They are no longer worth as much as when you bought them. So when you buy a car and then you go to sell a used car, what you purchase brand new is more than what you can sell it used. It's depreciating. So our R value is going to be the value of the car, 100%, whatever it is now, minus how much it is depreciating. In this case, it's 12%. So 100% minus 12% is 88%, better known as 0.88 in decimal form. So after 7 years, what is his car going to be worth? Well, it's the original value of the car times our rate raised to the n minus 1 power. So into a calculator that goes, put the right decimal in there. All right. I'm having technical difficulties here. All right. Let's see what I've got. And I want to, okay. I hit wrong buttons on my calculator. Give me 1 second. There it goes. All right. 325.33486. So this is what my calculator is displaying right now. It's the value of a car. Again, we're talking dollars and cents, so the value is going to be $15,325.33, right? And 33 cents. So if you are talking about people, if you're talking about things that can only be counted as whole number objects, I don't know how many of you use these, but stamps. If you need to put a stamp on an envelope, you either put one stamp on the envelope or two stamps on the envelope. You don't walk into the post office with 2.5 stamps. That doesn't make sense. Like you can't do that. Same thing with people. If you're counting the students in a class, each one of you counts as one whole person. That's how it works for people. When you're talking about dollars and cents for money, then yes, I expect dollars and cents, 2 decimal places to represent the cents that you have. Okay, I hope this helps. If you have any questions, let me know.